The ISS, a football field-sized space station orbiting around the planet. Chances are you probably already heard of it. It was a collaborative work for studies beyond Earth and uncovered the truth about the fragility of the human body in space over suspended amounts of time. Yeah, the ISS is pretty important, but what if I told you that it's in potential danger? Something as small as a paint fleck is hurtling around the Earth at disastrous velocities, so fast it could destroy a window or possibly the entire station altogether. Satellites all around the world, what our everyday practical technologies depend on, are all in the path of orbital space debris. Even future space travel could be jeopardized. Let me draw you a picture. In 2009, Iridium and Cosmos collided with each other, leading them to explode into over 3,000 fragments, knocking the collision possibility between a low Earth orbit satellite and debris over a centimeter up to 50% a year. The more the newly created fragmentation debris knocks into other objects, the more multiplied debris there is in orbit. This is the Kessler syndrome, which shows that in 15 years, the existing debris will triple if it remains in orbit. There's an estimated 100,000 tons of space junk with every satellite in orbit. That's about the weight of this aircraft carrier. All the debris certainly packs a punch, too. For instance, a drop of rain will fall on you with about 0.8 millijoules of energy. Now in orbit, a raindrop would have over 1,000,000 times as much energy, but its speed is only around 1,000 times greater, because in the kinetic energy formula, velocity is squared while mass isn't differed when multiplied. Space debris is a huge concern, so what can be done about it? Many satellites have a layered shield called a little shield to slow down the high impact of fragmentation debris. This shield consists of a thin wall that shatters debris into finer fragments, spreading the debris' kinetic energy into smaller impacts as it reaches a second, much thicker wall. Sometimes another layer is planted between the two that consists of high-impact materials, to slow down the energy even more. Down on Earth, scientists use a machine called a light gas gun to test out these shields. By using pressurized gas compressed by an explosive charge to fire at a small projectile to 19,000 miles per hour. That's average orbital velocity around Earth. If we wanted to find a satellite's orbital velocity, we could use this formula. Scientists are working to improve whipple shields. Rapid puncture-initiated healing replaces the middle layer with a liquid. So when the first layer is punctured by a projectile, heat and friction of the impact will provoke the liquid to plug up the hole, healing it. Much has been done to protect our satellites in the ISS, but as debris multiplies, how will we protect future space explorations? Good news is scientists and engineers have been developing anti-debris satellites that use harpoons, arms, nets, and magnets to take on trackable pieces of space junk, and even powerful lasers here on Earth. We've got a long way to go, but new innovations and discoveries are on the horizon to solve the impacts of space debris.